Hello engineers, welcome to Mechanical Training World channel. Today we will discuss about wind load calculations. You know right, when designing a pressure vessel, it's not just about considering internal pressure. We need to consider some external pressures like wind and earthquake loads, which can significantly impact our structural integrity. For example, imagine a pressure vessel which is standing tall in an open field. When a strong wind blows, the exact lateral forces that can cause us bending and overturning, right? So we need to consider all these forces. Today we will discuss about how to calculate stresses generated by the wind. So in upcoming sessions we will cover seismic as well. Before going to the topic, if you are new to my channel, please subscribe and click on the bell icon, guys. So let's get into the topic. So what is a wind, guys? What is wind in your point of view? So wind is a natural movement of air, right? Which is related to the planet surfaces. So how this wind forms? We know that due to sun, the air on the earth gets heated, guys. Whatever the air molecules in the earth get heated due to this sun heat, and it will go upwards due to less density, and the area in this part is empty, right? So this empty area is filled by the other dense air molecules. Whatever the particles after reaching some height, the particle gets cooled, right? Due to less temperature, and it gets dense and it will come downwards, like this circulation of air happens. So this causes wind, guys. So this is how wind forms. I hope you understand what is wind and how does wind forms. So wind flow has some speed or some velocity, right? Wind speed is a fundamental atmospheric quantity which is caused by air moving from high to low pressures, usually due to changes in temperatures. This is already I explained. So this is nothing but a wind speed, guys. So wind speed is generally measured by anemometer, and wind speed is used to determine wind loads, guys. From this wind loads we can calculate moments acting on the pressure vessel, and due to that moments we can calculate stresses generated. This is what we are doing today, guys. So due to this wind speed we need to calculate force and then moments and then stresses. So I need to conclude one more point here. Winds are different at different elevations and at different places. This is actually be seen in different areas. Wind speeds vary at different elevations and different places. Here you can see exposure and elevation diagram. Okay, this exposure and elevations have great impact on wind speed, guys. So if you see within a city at ground level near tall towers, wind is slower, like 5.7 meter per hour, 9.7 meter per hour, 14.9 meter per hour, like this. So due to these buildings, there is something obstacle is there, so that's why wind speed is reduced. If you see at higher levels within the same city, wind speed increases, right? It is flowing at 20 meter per hour. So because there is no obstacle here, so by this we can say elevation affects wind speed, with a higher location experiencing uniform and unobstructed wind flow and faster than the ground level, guys. So now we can see wind velocity. So from this we can say wind velocity is directly proportional to elevation to the power of n, where n depends on terrain profile, guys, whether it is opened or closed profile. So like this we need to calculate wind velocity. So from this, wind velocity is directly proportional to z power of n. V is equal to wind velocity, z is the elevation above ground level, and n is the terrain profile. So n depends on terrain profile. So this is the formula for finding out wind velocity, guys. So let's move into another point. So due to that wind velocity, so the surface feels some pressure, right? So that we need to find out. So we know that wind is related to fluid in nature. Dynamic pressure due to wind is Q is equal to half rho v square. This formula is somewhat looking like a pressure due to liquid, right? So in your 8th standard and 9th standard, you can learn about this formula. So as of now, I'm skipping. So this QZ is equal to half rho V square. So this 1.226 is the density of air, gas. So I already told you, right? This rho is that thing but density of air. So density of air is equal to 1.226 kg per meter cube. So if you calculate this, QZ is equal to 0.613 V square. So this is how we need to calculate wind pressure, guys. This is how we need to calculate wind pressure. After finding the wind pressure, we need to calculate force, right? We know pressure is equal to force divided by area. So force is equal to pressure into area. So here F is equal to QZ into area. So at what is the area here, guys? So if you see here, this is the wind force which is acting on this vessel, right? So this is the length which the wind is acting from the ground level, and this is the diameter of the tank. So area is equal to diameter into height of the tank, guys. So F is equal to QZ into A. That QZ is equal to 0.613 V square into D into H. This is how we need to calculate force. If force is there, it will create some moment, right? Here you can see. So due to this wind force, one side is tensile stress acting, another side is compressive stress acting. So due to this movement happened in this pressure vessel. So we need to find movement, guys. We know movement is equal to force into perpendicular distance, right? That is equal to force is equal to F and the perpendicular distance. It is acting at CG. So from the ground level. So M is equal to F into H by 2. That is in Newton meter, guys. Due to this movement, we observe some bending stresses. We know bending equation, that is M by I is equal to sigma by Y is equal to E by R. And we know section modulus is equal to I by Y max, guys. So from this we can find out sigma is equal to My by I. So My by I, guys. This Y comes to this side. So sigma is equal to My by I. So I by Y is equal to Z. So that is what here I written. So sigma is equal to M by Z. We know that for a simple cylinder, Z is equal to pi r square T. So this formula you can find in Dennis Moss book or other pressure vessel related books, guys. So I taken from Dennis Moss. So you can find this formula from Dennis Moss also. So if you substitute this value in the stress equation, you have the formula stress is equal to M by pi r square T. So this is how we need to calculate stress which is caused by the wind, guys. This is all about theoretical part, guys. So I didn't explain you code up to here. So I explained you in general terms. So if you see here, the dynamic pressure due to wind is 0.613 into V square. This is the theoretical approach. So if you compare this formula with the code formula, you will find some differences like KZ, KZT, KD, and KE. So this is all about theoretical approach. The theoretical approach is very simple, right? So velocity gives pressure, which leads to force, and then moment we need to calculate. So due to that moment, we can calculate bending stresses. So this is simple, but in practical scenario, it is different, guys. So the ASE 716 formula for pressure considers factors like kz, that means elevation, roughness factors, shape factors, directionality factors, important factors, and texting. So many factors are there. Likewise, the equation 0.613 v square involves factors like kz, kzt, kd, and kg. So if you want to know about kz, kzt, kd, ke, in next lecture we will discuss deeply about this uh, factors, guys.